coffee up for this, because this can get complicated. Doing complicated objects in perspective, I try to keep things simple because you'll see, again, go on YouTube and look up anything like drawing cylinders in perspective, and you're going to be seeing tons of lines and diagrams, and it gets to me to be really complicated. So I'm going to show you the complicated version of this, and then I'm going to show you the let's just eyeball it version. So I think it's important to understand still, even if it's complicated, it's still important to understand how this works. So I'm just going to draw, we're going to start with a cylinder. I'm going to start up here. Cylinders are round, but let's just pretend that on top of our cylinder we have a piece of paper cut out, a rectangular or a square piece of paper that's sitting on top of it. And I'm going to draw the midpoints. And so understanding how a rectangle works in perspective will help us understand a cylinder. So bear with me. Let me write this up here. Cylinder in perspective. And again, we'll just be doing 2 point. I really hope I spelled that right. So again, here's our square piece of paper that we've placed on top of our cylinder, and it is the exact same size, right? Not the exact same size, but it reaches the edges of our cylinder. So what does this look like in perspective? Well, I'm going to draw the midpoints, and I'm going to draw a cross. Now, in perspective, not only are these lines going to converge, but these are going to get smaller and these are going to get bigger, these quadrants. So let's draw this in perspective. The sides are going to get shorter. As things get shorter in perspective, that is called foreshortening. We're going to foreshorten. Right? So this gets smaller, these get smaller, things get foreshortened. As in, if you measure it with your eyeballs, they get smaller. And again, I'm going to divide it up into fourths. Now we're looking at this thing straight on. This thing is in 1 point perspective right on, so these won't change. But these on the side will change. Where are they going to go? Well, again, these quadrants will get bigger. And so I'm going to take this horizontal line, I'm going to move it back a little bit. And again, I'm just going to eyeball it. So again, this will be in 1 point perspective, but it all works out for 2 point as well. Right? So these are bigger, these are smaller. So that's our cut piece of paper in perspective. Now, to do a circle, let's just add our circle. So I'm going to add arcs that connect to the fourths, to the little divisions I've drawn. And I'm going to eyeball it and try to make them as even as possible. A little off on that one. That's awful, David. This is what happens when you don't do this often enough. Come on. It's just.
And it still looks pretty good to me.
Yeah, that's really good.
I'm kind of anal retentive. I'm just bad at it. Like, I want things to be perfect. I just can't do it very well.
Yeah, I get that.
You should see me in when I'm trying to do carpentry. It's hilarious. Okay, so again, to draw, and again, we're looking down on our cylinder just to understand how the circle on top of the cylinder is going to work. So again, these are all equal. These are not going to be equal, right? They're going to be a little fatter in the front, smaller and more squat in the back. So again, you're not drawing an oval. An oval is symmetrical. And generally speaking, when we draw an oval, it's going to be symmetrical. Well, this is not symmetrical. This is sort of weird and squat, sort of flattened back here and sort of fat up here. Again, if these are arcs of a circle and these are our tangents, it's going to be sort of weird and flat in the back and bulbous and sort of fat in the front. And so that's what a cylinder should look like, or at least the top of a cylinder should look like. Not like a perfectly symmetrical cylinder. Those two shapes are, let me make sure that's in camera. That's fine. This is more scientifically accurate. Now, do I expect you to do this whole thing every single time you do a cylinder? No. Because again, this gets too complicated. And I know like lots of art teachers have these systems where you draw in all these little lines and measurements and stuff every single time. For me, that gets in the way of observation and just looking. Looking, but understanding that, oh, what I'm looking at is a cylinder, but just make sure that the front part of the top of the cylinder is a little fatter and it's a little squatter, that it's not a symmetrical cylinder, it's a asymmetrical, or not a symmetrical oval, it's an asymmetrical sort of weird thing. So does that make sense conceptually? That we're looking down on a cylinder, and then when we shift that cylinder, when we go from here and we shift that cylinder from here to here, we shift that plane, we shift all of these little elements that we use to draw, again, a circle. So
Yeah, I understand. It's kind of just weird for me because when I saw the second thing you drew, I just automatically saw a hexagon. I meant a trapezoid.
uh-huh. Yeah, so this is a trapezoid. And again, this is the piece of paper we set on top of our cylinder. And I should, normally when I'm in a classroom, I have this stuff set up. I have it, but I don't have my cylinder, you know. I have jugs of paint that don't quite work as well. And I don't have the means to cut them very accurately. So when a square moves in perspective, you know, these sides and these quadrants we drew change. They get bigger as you are closer and smaller as they're further away. Like this line here that I drew moves away from us, right? And so again, a circle can fit into a square, and as we move that circle with our square, the front quadrants, these front sections will get bigger and the back ones will get sort of squatter. And again, if you want to try doing this today, just to practice, do this, right? Do this a couple times just so that the concept is clear. So you feel like the concept is sort of getting set in. Again, it's sort of making these concepts part of your intuition so that when you eyeball it, when you observe, you're like, okay, this is what it's supposed to be, so I'm going to push it towards what it's supposed to be. Again, nature doesn't always follow the rules, but generally speaking, when we're talking about perspective, the rules can't be broken. It's like gravity. So again, if I'm going to eyeball it, let's see, do I have a jug? I do have a jug. I can sort of paint my medium here. And I'm just going to eyeball it. I'm going to draw the back, and again, it's going to be kind of flattened and squat, and then I'm going to get a little bigger as I come forward. And I'm going to change directions. Again, I'm going to pretend that cross is there, even though it's not. I'm going to change the curvature of my circle here as I come around, and I'm going to do it asymmetrically. Because again, I'm sort of intuiting and sort of, I know that the front part is a little fatter, and this is, let's round this out a little bit. It's going to be a little bit fatter up front. And so that's my circle for, that's not quite looking right. I want this to angle out more. And again, I'm trying to make sure that I'm observing. I'm looking at my cylinder here. And again, making sure that I'm looking, not just faking it on the page. So I think a lot of artists do that. They say, this is how you draw a cylinder, and it's sort of very conceptual, and it's not observational. And I'm very observational. Again, I could draw a dolphin because I learned in the 4th grade how to draw a dolphin, right? You draw an oval here and an oval here, and then here's the fin. But does that look like a dolphin? No. I need to look at a dolphin, because then there's all those nice little subtleties and things that don't follow that rule that I can add, that add personality and add a sense of reality. That's a little bit better. So again, I'm drawing it sort of flat in the back. In fact, I can flatten it out a little bit more. And as I angle out and forward to the front of my cylinder, I could even go a little bit maybe fatter and rounder. Again, I'm being very chicken scratchy here because so that is much different than just drawing sort of a straight circle or an oval. So I'm trying to observe with the understanding. I'm trying to look at what I'm drawing with the understanding that, again, this, if I were to just sort of draw in, I'm trying to imagine the T, like where are those? They're, in this case, it's sort of at an angle, because again, this is in perspective, and so maybe I could draw it a little bit better and more accurate in perspective. So that's imaginary, but I'm trying to see it. I'm trying to see, okay, where is this at? Well, it's further back, and so I can see where the angle sort of changes from the back section to the front section. And then you're going to draw the sides. And again, I'm going to make this up. I'm going to stop looking at my actual thing here. Just to, again, draw a more traditional cylinder. I'm going to make sure I'm all the way at the edges, the very outer points of the top of my cylinder. Which will be, generally speaking, straight up and down. Again, this is mostly 2-point perspective. If this was a building and it was really tall and above me, then I would care about 3-point. Now, this is the cardinal sin of every single cylinder I've ever seen drawn incorrectly. This is always, always, always the case. I've seen it sometimes in this class. I've mentioned this, but again, not because of perspective, but just because it looks wrong. People draw their cylinders like this. What's wrong with that?
Flat bottom.
Yep. That is the cardinal sin. I see it all the time. I've done it. So if you think about, we're above our cylinder, right? And as the cylinder goes down, we're sort of seeing more of the bottom. We're getting more above. So imagine a basketball hoop, right? Imagine you're the ball traveling towards the basketball hoop. at some point you're straight on. Here's the ball, here's the hoop. You're straight on with it, so it looks flat. But as you get above it, you're seeing more of the circle. Again, I used to play basketball, so I imagine being the ball and getting more above the hoop and seeing more of the roundness. So as we're above this cylinder, and we see a lot of the top here because it's close to us, we're going to see quite a lot of, again, imagine it's sort of transparent. We're going to see quite a lot of the roundness of the bottom part of this circle. It's going to be quite round. And again, that's a function of perspective. This part will start, again, in 3-point perspective, this part might start getting smaller as it's, because again, this is further away from us, right? And we're more above it because it's further away. And so this circle, again, imagine this circle is going to be almost perfectly round as compared to this one, which, as it gets closer to our eye line, starts to flatten out. So again, if I'm just going to eyeball a cylinder, and I'm just going to make one up that's a little bit more flat. I'm going to make this sort of rounder. And again, I'm just terrible with the chicken scratch this morning. Not feeling too confident with my drawing skills. So flatter in the back, I'm going to kind of come out and get a little fatter up front, a little rounder up front. So again, think of this as a cylinder that I'm not looking at. I'm seeing less of the top. So again, not a symmetrical oval, but a sort of weird oval-like shape. It's not great, but the furthest point out on the furthest point on the left or right side is where I start my lines going down. So it's not going to be here, it's not going to be here, it's going to be sort of up here again, because remember that outermost point corresponds with this cross section that we are imagining, and so it's going to be up here. Again, it's further back. And again, as I get down to the bottom, and I tend to exaggerate, I'm going to make the bottom rounder than this. It's not going to be parallel to or equal to, because again, in perspective, my point of view is changed. Right? My point of view of this part is different than this part because again, they're in different points in space, and so my perspective therefore changes. And again, I'm just sort of imagining these cross sections. But I like them because they're helpful, because if you can imagine where they are they more like this, or is this thing sitting more like this? That changes it. That changes our cylinder a little bit. You know, maybe our cylinder is more like this. Well, it's going to change where we draw our arcs, where we draw the sides, where we flatten it out, and where we make it bigger. If you really want to make something look like it's in three dimensions, if I draw my cross section like this part of it's going to be the biggest part because it's the closest part to me. So I'm going to make that a little bit more bulbous. In fact, I can really exaggerate that. Again, this is just pretending that there's a square sitting on top of it. And what does a square look like in perspective? Well, I can now break this into fourths, draw each part of the circle in 4 sections, breaks it down a little bit more. So you could just draw each section. So this section you can see is bigger than this section. And since I've moved my cross, I'm going to put the edge of my cylinder here. And this one's going to be more sort of up here. And again, the bottom will be just more round. And again, I can kind of draw my imaginary cross section to get a good sense of where my angles change. And again, that cross section is just telling me where does the angle from the side change to the bottom. And I'm going to even them out a little bit because it's never a perfectly straight angle. It's always going to be a little bit round.
And the bottom angle usually follows the top angle in shape.
In perspective. So this angle and this angle will converge at a vanishing point. So they won't be exactly parallel. Again, imagine this being a square. Squares we understand by now. So this is going to a vanishing point over there somewhere. And so this might be a little steeper, honestly. And I'm making this more complicated than maybe it needs to be. But I really want to emphasize kind of how to understand a circle, which is what a cylinder is. A circle is just a cylinder is just a circle that's been stretched out. How to understand this circle in terms of perspective. And we understand how cubes and squares work. Those are easy. So again, I don't need you to draw these lines. I like knocking them in, I sort of eyeball it. I do it really quickly to kind of, again, break my circle that's in perspective into fourths, so it's a little bit easier to draw. And to understand the angles of perspective. And I'm just looking at my cylinder here, and this is what I'm seeing. I'm really trying to imagine that plane that's sitting on top of it, and the lines of perspective that I'm drawing have more to do with this room, right? This angle is really determined by the angle of the table. This is sitting on a table, and the angle of that table is right here. And so this is sitting on a table. That plane is parallel to the table of the plane of the table, right? Those flat surfaces are parallel. And so I'm just going to kind of match them up. And so this line really is determined by my environment here, which way the table and the roof. So that line of perspective, that vanishing point that's out there somewhere, because I've got this wall, I've got the table, I've got everything converging sort of that way. And so on my cylinder here, I'm going to point it that way. And same with this part, like the second vanishing point is that way somewhere, because I've got my table and this wall, and so this one's going to go kind of that way. And so it's all determined by the environment a little bit. And I intuited that. I kind of vaguely understood it because I'm seeing this plane, and so I'm going to be like, everything's angled that way. So I'm going to angle them that way. And same with this. Again, the vanishing point is that way somewhere. And so I'm going to angle this a little bit, and then that determines where this and this change is from the side going down to the bottom. And again, I want to make sure that my bottom part of my cylinder is rounder than the top. You can even, draw where does this change need to happen. Well, it's going to be right along that, and so I can really use that as a guide. Now, you can draw all these little teeny lines in here, and you can really get into the weeds with it. That to me it's very diagrammatic and gets in the way of looking at the thing. If you're looking down here and being like, okay, well, this is supposed to be here and this is supposed to be here, where am I looking? I'm looking at my drawing, not at what I'm supposed to be drawing. I'm going to be drawing that. And so as I observed, that's where all of a sudden my T-shape changed and my drawing became more about what I'm seeing here. With kind of the understanding, and when we talk about refining your drawing, the refinement happens when, okay, I've drawn that, I've got something on my paper here, okay, doesn't quite look right. Well, what's it supposed to look like? Oh, well, I just need to adjust the roundness of the bottom of my cylinder, because I was told that the bottom needs to be rounder. I need to avoid that sin of flattening out the bottom. So I hope that's clear for cylinders. I'm going to pause the recording, and we're going to get into some more complicated 3D, 3-point perspective rather, ideas for our invented city. Any questions before we pause? Nope. Okay.